I'm going to share my screen because we're going to move to the second part of our Green Chemistry Connections, which involves the Latinx Chem presentations. So Latinx Chem Twitter conference is a conference that happens on Twitter every year. And we had a lot of beautiful signers from Brazil actually presenting in this conference. And now they're going to be presenting for us where they presented there. And also we're going to put the links of the posters on the chat so you can have access to the posters while they're presenting. But we have now two presenters from UNESP. So Cynthia, she is our GCCSigner at contact at UNESP. So if you have any questions about how the GCC is going on at UNESP, feel free to reach out to her. Sorry, Cynthia, I'm putting you on the line here, but yes. So the first one, we're going to hear from Leticia. She's going to talk to us about the UN Sustainable Development Goals in Green Chemistry, contributions to undergraduate teaching in chemistry and chemical engineering. Leticia, she holds a licentiate degree in chemistry from São Paulo University, and she's currently a master's student in organic chemistry in the area of biocatalysis and green chemistry at the same university. And Fernando, he's going to talk to us about QR codes, and he won the Best Poster Award in the Latinx Chem Nanomaterials category. So we're very excited to have him here. Fernando is a PhD candidate. He's enrolled in a doctoral degree in chemistry and physics between UNESP and University of Aveiro in Portugal. His research focused on the sustainable development of new materials for applications in photonics, such as organic inorganic hybrids, OLED substrates, and luminescent thermometers. He's a Marie Curie Fellow, currently working on the FunGlass project, funded by the Research Innovation Staff Exchange from the Marie Curie Actions. So, Leticia, I'm going to stop sharing my screen and invite you to share yours to tell us about your work in the UN Sustainable Development Goals and green chemistry.
I'll share my screen.
Perfect, Leticia.
Okay. Good evening, everyone, or good morning, or good night, I don't know. My name is Leticia. I'm a master's student at UNESP. My advisors are Professor Cynthia and Humberto Milagre. And this work I'll present to you is titled UN Sustainable Development Goals and Green Chemistry, Contributions to Undergraduate Teaching in Chemistry and Chemical Engineering. This work is a result of the activity developed during the discipline of sustainable chemistry that is offered at the Institute of Chemistry at UNESP. And the target groups are graduate students of chemistry, chemical engineering, and related areas. Here is the course syllabus, so I'll point out a few things. The discipline is worried about the student's citizenship profile. So the point is that to be a good chemist, you have to be able to think critically, not just know the process of chemistry, but also think about how those processes impact the environment and the society. So this is the general objective of this discipline. I am the teaching intern through the program PAADES. That is a program of activities and improvement in teaching in higher education. And the first thing was introduce the SDGs and green chemistry to the students. Then we send these 2 articles for them to read at home about the UN Sustainable Development Goals before the next class. And after they read those articles, we apply the jigsaw didactic strategy. I won't go into details about how it works, so it's not too extended, but it is a cooperative learning method in which students discuss a topic in groups, and then they change the groups and explain that topic to their colleagues. So in the end of the class, all students know about all topics. This is the document was used to this didactic strategy. It shows the frequently asked questions about the Sustainable Development Goals. So it distributes 3 questions for each group, the way I showed in the previous slide. Then we had the chemistry week at the university, and it was made a workshop about the SDGs, where the participants assembled 20 cubes and wrapped the cubes with each 17 SDG sticker. They discussed and pasted post-its with a reflection or a tip on how chemists can act to accomplish each SDG, and later the cubes was put on exhibition in the Institute of Chemistry. Here are some reflections and tips put forward by students. I read just an example, the development of less aggressive biopesticides for the SDG 2, Zero Hunger. So the students showed interest in the subject as they all participated and took the discussions in depth. And we could conclude that the activity fulfilled the objective that was link our role as chemists with meeting the Sustainable Development Goals. For me, the teaching intern, the contribution of this discipline and this work was to put on practice didactic strategies that were studied only in theory and during my graduation, and reflect about the results of the application. And also it was good to learn more about the sustainable and green chemistry and be able to discuss the topics with the students and with the professors, contribution to training both as chemists and as a teacher. And the community of the Institute was also able to interact and learn about the 17 SDGs. And now the cubes are for exhibition till the end of the year at the university. And that's it. Thank you very much for your attention.
Thank you so much, Leticia. These are very cool. And I think Ed Brush is here because he was at the ACS spring meeting. We had these cubes and I was going banana with all of them because I really want to take pictures. It's really cool, this idea of the SDG cubes. So, okay, so do you have any questions for Leticia? You just unmute yourselves or write them in the chat. Okay, Leticia, I do have one question for you because whenever I was in Brazil, we didn't used to talk a lot about the SDGs in a university or anywhere, to be honest. So do you think that this is changing over there? Like, do you think people are more and more aware of the SDGs in terms of like the curriculum, the universities, the chemistry students? How do you think it's the UNSDGs promotion over there?
This is a discipline that is, I don't know how to say that word in English, but optativa.
It's optional, yeah.
Optional, okay. But this was the first time I saw the SDGs in the classes, so I think that it's not into the graduation yet, because it's supposed to be it's supposed to not be optional.
Yeah, optional. I don't even know.
Optional. I think it's supposed not to be optional, but it is. So that's a thing that needs to be improved. So
yeah, no, I agree, Leticia. And also we have people in the chat. I know Brijesh, sorry, he did some events also about the SDGs in India, which is really cool. So we'll change that. We'll keep working to change that. So thank you so much, Leticia. And now we're going to move forward to Fernando Maturi to talk about his QR codes and how to make them sustainably.
So I hope you can see my screen right now.
We do. It's not on the presenter mode, but we do see your screen.
Okay. How about now?
It's thinking on my side. It's still thinking.
Okay.
Yeah, I still see it normally, but it's fine. Fernando,
maybe I think I know what is the problem. I need to maybe to present first, putting the presentation mode. Yeah, I think it's this one. Yeah.
Yeah, great, Fernando.
Yeah. Okay, so can I start?
Go ahead.
Okay, so hello everyone. My name is Fernando Maturi. I'm a PhD candidate currently working at the São Paulo State University in Araraquara, Brazil. And I'm here today to show you a bit of my research work where we are using upconverting nanoparticles and also recycled plastics in order to develop new QR codes for anti-counterfeiting applications. So upconverting nanoparticles are nice materials because they present visible light emission upon the infrared radiation. So we can use this kind of emission because they vary with the temperature and also they vary in color. So this material is quite nice in order to develop new thermometers and also to perform applications in color tuning. So this is a quite interesting material. In our research group, we have decided to use expanded polystyrene in order to host converting nanoparticles because nowadays EPS is a big environmental problem because everyone uses it because it's quite cheap to buy and we are used to apply it for packaging and storage food. So you just need to buy, you discard it, and that's it because it's cheap. So you don't need to care about recycling. So we have a bunch of EPS right now that's not being recycled. But in fact, it's quite easy to recycle EPS because we just need to dissolve it in a solvent such as the D-limonene and this one is a great choice because it's extracted from orange. So it's a renewable source solvent and it also presents a lower toxicity compared to other solvents such as toluene and chloroform. So we can easily perform the recycling of EPS for developing new materials. So in our work, we have decided to combine the advantage of recycling polystyrene with D-limonene with the upconverting nanoparticles to develop new luminescent inks because we can print these inks by using a serigraphic printing method to print new luminescent QR codes. And these QR codes are different because besides the common applications in store information such as web pages or email addresses, now we have this light emitting feature arising from the convert. If I radiate this new light emitting temperature, the changes in these emissions bands to define a new parameter that can be recorded as a function of the temperature to get a new calibration curve that can be used to perform thermal readouts with this QR code. And in addition, we can also change the power of the laser that has been used, that is being used to irradiate the QR code and follow the changes in the intensity of the emission band arising from the nanoparticles inside the QR code because we have the emission in the green and the red spectral range. So when we change the power, we also change the color of this emission band. So we can combine both of these features within the QR code and set thresholds to validate the information inside the QR code because at a specific laser power, we would expect a specific color of the emission of the QR code. And at a specific temperature, we also would expect a specific ratio between these two emission bands. So we can check by looking into the color and the temperature, we can see if the QR code we are using is the original one. So we can use this to produce banknotes and stamps for really important documents in a really simple way. And what is more interesting about this work is that we can in fact replace the use of a spectrometer to assess this information because we are already using a smartphone to read the QR code, but we also can take picture of the QR code while it's being radiated and decompose the pictures in different color channels and taking the red and green color channels as we do in the emission spectra of the nanoparticles to evaluate the change in color. So we have a different and easiest way to assess the information, the different information in this QR code. So this is such a great advance in the field that this year we got the front cover of the Advanced Photonics Research regarding this work. So you can follow the complete description of this work here. And we also, as Juliana mentioned, we also got the award for the best poster regarding this work in the Chem Nanomat session in the Latinx Chem conference. So the take-home message I have for you today is that it's indeed possible to use a sustainable, cheap, and fast approach to produce luminescent QR codes with thermal sensing and color tuning properties for anti-counterfeiting applications. So I hope you have liked it, and thank you for your attention.
Yay, thank you so much, Fernando. I was really excited when I saw your poster and all the GIFs moving. It's really nice and all the colors. So everyone, do you have any questions for Fernando and his sustainable QR codes? I see a lot of nice things in the chat. Everybody saying congratulations.
Yeah, thanks, guys.
Yeah, Fernando, I had a question about the solvents that you used. I think I asked you in the Twitter. I don't remember. Like you mentioned the D-limonene, is that it?
Yeah.
Have you ever tried like other solvents that are also renewable and in that sense, or like, no?
We have tried a bunch of solvents and all of them worked, but the biggest problem we had was that most of them were like too volatile, so we couldn't like perform the printing of the QR codes. So that was one of the main issues. But I think the main motivation of choosing D-limonene is because we are in the orange region, so we have a lot of industries producing orange juice around Araraquara. So we can get like a bunch of limonene. It's really cheap, and it's like the same chemical, the same analytical grade from if you compare to the Sigma one. So it's quite cheap.
That's awesome, Fernando. Thank you. So Eder is asking in the chat if you tried another polymer to use.
We also tried polymethyl methacrylate as well, PMMA. We have also, but it doesn't work with D-limonene, so we needed to use chloroform. So it was not that nice in the green chemical point of view. So that's the reason we decide to go with polystyrene. And I can see that there's a question about the nanoparticle size. We also choose this particle because different from quantum dots or metallic nanoparticles, we don't change the optical properties by changing the size. The optical properties arise from the doping of the particles. It comes from the ions inside the nanoparticles. So regardless of the size, we also have the same optical properties. So that's the reason we choose this kind of nanoparticle.
Awesome. Thank you so much, Fernando, for your amazing presentation. Congratulations again for your award. So I'm going to share my screen. Thank you also again, Leticia, for your amazing presentation. I muted myself instead of sharing my screen. Awesome. So, okay, so we're going to take a break, everyone, so we can breathe. So please, if you could be back by 12:50. So in my cell phone, it's like 12:42 now. So if you could give 8 minutes and come back, we'll be back with our presentations. We'll have more Latinx Chem, green chemistry happening for you in the connections. So take a break and we'll be back by 12:50. Thank you.